Tonight's homework assignment is watching a video on squares and square roots. So first we're going to start with our vocabulary words. An exponent is a number that tells you how many times, the base is being used as a factor. And if you remember, a factor is just a number that is multiplying by another number. So for example, if I had 5 with the little 3 in the corner, that is a picture of an exponent. This is an exponent right here. It's a number that's telling me how many times I'm going to be multiplying that base. And the word base is the number used as a factor. So this number right here, the 5, is our base. The exponent is the little 3, the little smaller number. The larger number is the base. It's the number that you're actually multiplying. Powers. Powers are numbers expressed. That's another word for written. So numbers expressed or written using exponents. So this entire thing, 5 to the third power, is called a power because you could say 5 to the third power. Or if this was a 2, you would say 5 to the second power or 5 to the fourth power. This whole entire thing with a base and an exponent is called a power. All right, a square. A square, we all know what a square looks like. It has all equal sides. It's a 2D shape. But if you're talking about the square of a number, it is the product, that's the answer when you multiply, of a number and itself. So it's the product of a number and itself. So if I had 5 to the second power, I could say 5 to the second power, or I could say 5 squared, because I know to solve this, I would do 5 times 5. And 5 times 5 would be 25. And it would make a perfect square, because all sides are equal on a square. So 5 by 5 would make 25 as the area. That's why we can say it's a perfect square. Cubed is very similar to square. A cube is a 3D shape, so it just has one more side. So it is the product in which a number, so the product in which a number is a factor 3 times. So instead of it being 5 times 5, it would be if you have a third power, meaning if you had 5 times another 5, you have it 3 times, which that would make a perfect cube. Because if I had this, and you don't have to draw the cube, but I just want you to see that if you had a cube, you would have 5 by 5 on the bottom to make your square, and then you would also have a 5 as the height, and it would be 5 times 5 times 5. So it makes a perfect 3D shape, a cube. So you could say 5 to the third power or 5 cubed. Square root is a new word to use. Square root. This is only one of the 2 equal factors of a number. So it is the side of a square. This little symbol right here is the square root symbol. That little symbol right there is the square root symbol. It represents one of the 2 equal factors. So for example, if I had 25 and I wanted to take the square root of it, I want to know what times itself would make 25? Well, it'd be one of the two sides. So a perfect square would be 5 by 5. So one of the sides would be 5 long. That's the root of the square, what created the square. That's what the little square root symbol means. It does not mean to divide. I'm not dividing it by anything. I'm just saying what times itself makes that perfect square. And it's 5 times 5. All right, let's go to our notes, and we're just going to underline and highlight a few things that are important down here. 2 or more numbers that are multiplied together form a product, and they are called factors. We did already learn that earlier, that factors are when you have 2 or more numbers being multiplied together. They're being multiplied. So we did already learn that when we were doing decimals and fractions. When the same factor is being used, then you may use an exponent. So an exponent is when you're multiplying the same numbers over and over and over again. For example, 2 times 2 times 2 times 2. If you were to multiply all those, you would get 16. But another way to write this big long number is to have a base of 2 and an exponent of 4, because there's 4 of them. So if we go to this one right here, we know 3 times 3 is 9, but we could write that as 3 to the second power or 3 squared, because it would make a perfect square, 3 by 3, if I wanted to draw that. All right, numbers expressed using exponents are called powers, and we talked about that up here at the top, numbers that have exponents. So if you had 5 with a little 2 by it, that would say 5 to the second power or 5 squared, because you could draw a perfect square of 5 by 5, 5 times 5. Okay, then 7 to the third power is 7 to the third or 7 cubed. That means you could draw a perfect cube, and you don't have to draw the cube. I'm just showing you. 7 times 7 times 7. And then 3 to the fourth power would just be 3 to the fourth power, because we don't have a 4D shape. Write each of the powers as a product of the same factor. So they want you to write it out how it would look. 6 to the fourth power is just 6 times 6 times 6 times 6. So if I do this one, it would be 9 times 9 times 9 times 9 times 9. You don't actually have to solve it. You can just write it out. Now you try example number 5 real quick on your own. Numbers written without exponents are called standard form. So if they don't have an exponent, then it's called standard form, where you write it all the way out. It says evaluate each expression. Example number 6. 2 to the fourth power is 2 times 2 times 2 times 2, which would be 16, because they multiplied all of them. If I did 3 to the fifth power, that would be 3 times 3 times 3 times 3 times 3. That means I would multiply 3 times 3 is 9. 9 times 3 is 27. Then I would times by 3 again, which would be 81. And then 81 times 3 again would be 243 if I were to multiply all those 3's together. I'm not going to make you multiply on number 8, but I want you to at least write it out what 4 to the fourth power would look like. If you want to solve it, you can. All right, at the bottom it says write each product with an exponent in exponential form, because numbers that are written with exponents is called exponential form. So you scrunch all the numbers up with a little exponent. So this one, there are 3 12s. So 12 is our base. 3 would be our exponent. So this is 12 to the third power or 12 cubed. You can try the 6 by 6. Okay, flip it over. The area of a square is 4 by 4 or 16 square units. So the product of a number and itself is called the square, and we've already talked about that. If you have a number and itself and you multiply them, that's what product means, It's called the perfect square of that number. So it says find the square of 3. So find the square of 3. If I draw this 3 times 3, that would make a perfect square of 9. Okay, this one says find the square of 8. So right over here you could find the square of 8 and you could draw it, and you try that one. Alright, the next part, numbers like 9, 25, and 100 are called square numbers or perfect squares because they are squares of whole numbers. The factors being multiplied form perfect squares, and you can take a square root symbol of a perfect square. So when you have these, they're the same whole number over and over. Same whole number being multiplied to make a perfect square. So if I had square root of 81, that means if I had a perfect square of 81 squares, there were 81 little bitty squares in here, I want to figure out what times itself, what whole number times itself makes 81. And that'd be 9 times 9. So the root of 81 little squares is 9. That's how many would be on every side. If I did 64, I know that if I had 64 little squares, 8 times 8 makes 64. So 8 would be the perfect square root of that. I could also think of 16 times 4 makes 64, but that would not make a perfect square. It would make a big long rectangle if I had 4 by 16. It would not make a perfect square, 8 by 8. So that would be incorrect. Okay, you can try example number 5, square root of 144. Think about what times itself could make 144 squares. Now it says find the square of each number and draw the model. So if I were to say 2 squared, that would equal 4. So if I drew a model of it, I would do 2 by 2, 2 rows, and 2 inside. So I would have 4 total in the inside. If I was going to do 5 squared, 5 to the second power would be 25. So if I were going to draw a model, I would draw 5 rows, and then 5 rows the other direction, and I would have 25, 5 by 5. Okay, then you can try example number 8 and try 6 squared to see how it would be. For the rest of these, I want you to try them. I want you to see if you can draw a model for 7 squared, and then you try solving the rest of them. And have your notes completely filled out front and back when you come to class tomorrow.